Hi everyone, I am Mrs.K.DEVI, Assistant Professor of Computer Science, A.D.M.COLLEGE for Women, Autonomous, NAGAPATTINAM. Today, discuss about the data structure and types. Introduction. Data structure affects the design of both structural and functional aspect of program. Program means algorithm and data structures. You know that the algorithm is a step-by-step procedure to solve in a particular functions. That means algorithm is a set of instructions written carry out certain tasks, and the data structure is the way of organizing the data with the logical relationship retained. To develop a program of an algorithm, we should select and appreciate data structure for the algorithm. Therefore, the algorithm and its associated data structures from a program. Definition. Data structure is representation of the logical relationship existing between individual element of data. In another word, a data structure is a way of organizing all the data items that consist of not only the element stored but also their relationship to each other. Classifications of data structure. Data structure are normally divided into two broad categories. First one is the primary data structure. The second one is non-primitive data structure. The first one is primitive data structure. There are basic structures and directly operated upon by the machine instructions. In general, there are different representation on the different computers. Integer, floating point numbers, character, constants, string constants, pointers, etc. Non-primitive data structures. There are more sophisticated data structures. These are derived from the primary data structure. The non-primitive data structure emphasized on structuring of a group of homogeneous or the homogeneous of different type of data items. List, stack, queue, tree, graph are the example of non-primitive data structure. The design of an effective data structures must take the operation to be performed on the data structure. The most commonly used operation on the data structure are broadly categorized into the following types. The first one is create, selection, updating, searching, sorting, merging, and destroyed or delete. Differentiate between primitive and non-primitive data structure. The primitive data structure is generally a basic structure that is usually built into the language, such as an integer, a float. A non-primitive data structure is built out of the primitive data structure, linked together in meaningful ways, such as linked list, binary search, and tree, and AVL tree, and graph, etc. Arrays. An array is defined a set of finite number of homogeneous selected as the same data type. It means an array can contain one type of data only, either all integers, all floating point numbers, or all characters. Simply, the declaration of array is follows the general format int ARR 10. The 10 is indicated to the square bracket, where int specifies the data type or type of elements arrays stored. ARR is the name of the array and the number of specified inside the square bracket is the number of elements an array can store. That is also called size or length of array. Following are some of the concepts to be remembered about the array. The individual element of an array can be accessed by specifying name of the array following by indexed or subscripted inside the square bracket. The first element of array has indexed 0. It means the first element and the last element will be specified as array 0 and array 9 respectively. The element of array will be always stored in the consecutive memory allocation. The number of elements that can be stored in an array, that is the size of array, the length is given by the following sequence. Uppercase hyphen the lower bound plus 1. For the above array will be 9 plus 0 declared to the square bracket plus 1. The initial value is 10, where the 0 is lower bound of an array and the 9 is the upper bound of an array. The array can always be read or written through the loop. If we read one-dimensional array, it required one loop for reading and the other for writing the array. Small example of the reading an array. For function bracket I equal to 0, I less than or equal to 9, I plus plus. If we are reading or writing two-dimensional array, it would require two loops. And similarly, an array for the n-dimensional would be required n loops. Some common operation performed on array are creation of an array, traversing an array, insert of new elements, deletion of required element, modification of elements, merging of elements. Next one, list. The list means the linear linked list. Can be defined as the collections of variable numbers of the data items. Lists are the most commonly used in non-primitive data structure. An element of the list must contain at least two fields. One of storing the data or informations and another for storing the address of next element. As you know, for storing address, we have a special data structure of the list. The address must be a pointer type. Technically, each such element is referred to as a node. Therefore, a list can be defined as a collections of node as shown below. The types of linked list: single linked list, doubly linked list, single circular linked list, double circular linked list. The first type, single linked list. A single linked list is a unidirectional linked list. So, you can only traverse in one direction. That is, from head node to tail node. Structure of single linked list. There are many applications for single linked list. One common application is to store the data of items that need to be produced in order. For example, a singly linked list can be used to store a list of tasks that need to be completed, with the head node representing the first task to be completed and the tail node representing the last task to be completed. Single linked lists are also used in the algorithms that need to process a list of items in the reverse order. For example, the popular sorting algorithm, the quick sort, use only the singly linked list to store the list of items that need to be stored by processing the list in the reverse order. The quick sort can sort the list more efficiently. Doubly linked list. A double linked list is a bidirectional linked list. So, you can traverse in both directions, unlike the single linked list. It node contains one extra pointer called the previous pointer. The pointer point to be the previous node. Structure of double linked list. A doubly linked list, singly linked list is a data structure that consists of the set of single linked lists, each of which double linked list. It is used to store data in way that also first insertion and deletion of the element. Circular linked list. A circular linked list is a unidirectional linked list. So, you can traverse it in only one direction. But its type of linked list has its last node pointing to the head node. So, while traversing, you need to be careful and stop traversing when you revisit the head node. Structure of circular linked list. A circular linked list is a type of data structure that use the linked list technologically to store the data in the linear, sequential fashions. However, unlike the traditional linked list, a circular linked list has no beginning or end. It is essentially a ring of nodes. This makes the circular linked list ideal for applications where data need to be processed in the continuous loop, such as in the real-time applications or simulations. Circular doubly linked list. A circular doubly linked list is a mixture of a double linked list and the circular linked list. Like the doubly linked list, it has an extra pointer called the previous pointer, and similar to the circular linked list, its last node point at the head node. This type of linked list is a bidirectional list. So, you can traverse it in the both directions. Structure of doubly linked list. A doubly linked list is the variation of standard doubly linked list. The first and last node are linked together, forming a circle. This allows for quick and easy traverse for the entire list without the need for special case handling at the beginning or end of the list. The DCL are often used in the applications where the data node to be processed in a sequentially fashion, such as the videos or audio player. The applications of different data types of linked list. A linked list is used to implement the stack and queues. A linked list is used to present the sparse matrix. You can implement and image the viewer using the circular linked list. You can use the linked list concept to navigate through the web pages. The last one is you can use the circular doubly linked list to implement the Kubernetes heaps. Next, stack. A stack is also the ordered collections of elements like arrays, but it has the special features that deletion and insertion of elements can be done only from one end called the top of the stack. Due to this, properties is also called the last in first out. The type of data structure means LIFO concept. A stack of plates placed on the table in the party. A guest always take off the fresh plate from top and the new plate are placed onto the stack at the top. It is the non-primitive data structure. When an element is inserted into the stack or removed from the stack, its base remains fixed, where the top of the stack changes. Insertion of the element into the stack is called push, and deletion of the element from the stack is called pop. The below show the figure how the operation to be taken place on the stack. The stack can be implemented into the two ways. Using array, it means the stack implementation. Second one is using the pointer, it means the dynamic implementation. The another topic is queue. The queue are the first in, first out type of the data structure. It is called the FIFO concept. In a queue, new elements are added to the queue from one end called rear, and the elements are always removed from another end called the front end. The people standing in railway reservation row are an example of the queue. Each new person come and stand at the end of the row, and the person getting their reservation confirmed get out of the row from the front end. The below show the figure how the operation take place on the stacks and queue. The queue can be implemented in two ways, using the array implementation and using the pointer implementation. Tree. The tree means a non-linear data structure. A tree can be defined as a finite set of data items. It means called the node. The tree is a non-linear type of data structure in which the data items are arranged or stored in the stored sequence. Tree represented the hierarchical relationship between the various elements. There is a special data item at the top of the hierarchy called the root of the tree. The remaining data items are partitioned into the numbers of mutually exclusive the subset, each of which it will itself a tree, which is called the subtree. The tree always grows the length towards the bottom in data structure, unlike the natural trees which grows the upwards. The tree structural organized the data item into the branches which related the information. Graph. A graph is a mathematical non-linear data structure capable of representing many kind of physical structures. It has found applications in the geography, chemistry and engineering sciences. Defining the graph. A graph G means V and K, vertices and edges, is a set of edges is called the graph. An edge connected a pair of vertices and may have weighted such as length, cost and another measuring instrument for according the graph. The vertices on the graph are show the point are circulars and edges and are drawn as the area or line segment. The types of graphs: direct graph, indirect graph, simple graph, weighted graph, connected graph, non-connected graph. Direct graph. A graph in which the edges can have direction. That means the edges have arrow indicating the direction of traversal. Example, a web page graph where link between the page are directional. Undirectional graph. A graph in which the edges have no direction. That is, the edges does not have the arrows indication the direction of the traversal. Example, a social network graph where the friendship are no directional. Next one is the simple graph. If each pair of nodes or vertices in a graph, that is G of V comma E, has only one edge, it is a simple graph. As a result, there is a just one edge linking two vertices, one-to-one interactions between the two elements. Weighted graph. A graph in which the edge have weighted or cost associated with them. Example, a road network graph where the weight can be represented the distance between two cities. Next one is the connected graph. There is a path between two vertices of the graph data structure and any other vertices the graph is connected. Undirected graph, where there is no edges linking the vertices, you refer to the null graph as a disconnected graph. The last one is completed graph. A graph in which each vertices is connected to every other vertices. Example, a tournament graph where every player play against every other players. Thank you.